Hello boys and girls and cougar parents. Today we're going to do a little more practice using the Pythagorean theorem. One, to find the missing side of a triangle, a right triangle. Okay, it has to be a right triangle. And two, we're going to use the Pythagorean theorem to test to see whether or not a triangle is a right triangle or not. Because the Pythagorean theorem only works with right triangles. Let's get out our homework and do a couple sample problems together. Boys and girls, let's take a look at number 4. We need to find this missing side, which happens to be a leg of our right triangle. Again, we're going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. Our height here we don't know, so that's going to be x. Our base is 60. We need to square that. And our hypotenuse is 100, which we're going to square that. That's c. Okay, so let's bring down our mathematical information. 60 times 60 is going to be 3,600. And 100 times 100 is going to be 10,000. Okay, then I need to subtract 3,600 from both sides. I want to isolate the variable x. I get x squared is equal to 0, 0. Got to do some regrouping. It's going to be 4, and then 9 minus 3 is 6. And then I need to find the square root of both of these because I want to do the inverse operation. The inverse operation of squaring something is finding the square root. And the square root of x squared is going to be x is equal to, and that will be 80. 80 times 80 is equal to 6,400. Let's take a look at number 9 on the front sheet. Okay, actually this is number 10. This is number 10. Problem number 10. We've got a right triangle here, and our measurements are in inches, and they're also decimals, so it's going to be a little more work, but we can still do it. We've got a squared plus b squared is equal to c squared. This is the formula, the Pythagorean theorem, which we use to find our missing side. We don't know our height. That's just x. Our base is going to be 5.2 to the second power. And then our hypotenuse is going to be 8.4 to the second power. Let's do our calculations over here. Well, I'll do this one first. 5.2 times 5.2. 2 times 2 is 4. 2 times 5 is 10. Put a 0 there as a placeholder. 5 times 2 is 10. Carry the 1. 5 times 5 is 25. Plus 1 is 26. I got 4, 0, 7, and that looks like 2. So this is x to the second power plus 5.2 times 5.2 is going to be 27 and 400ths. Oops, right there. Okay, then I got to do 8.4 times 8.4. 4 times 4 is 16, carry the 1. 4 times 8 is 32, plus 3 is 33. 8 times 4 is 32, carry the 3. 8 times 8 is 64, plus 3 is 67. 6, 5, 10, carry the 1, 7. So that's equal to 7,056. Okay, I need to isolate. Oh, no, it's not. Hold on here. I need to erase that. See what happens when you're rushing. And I also have the crazy basketball team next to me, and they're too loud. Okay, gotta remember my decimal point. Okay, 8.4 times 8.4 is 70 and 56 hundredths. Okay, now I need to isolate my variable, so I subtract 27 and 4 hundredths from both sides. Okay, these guys cancel each other out, and I'm left with x squared is equal to 6 minus 4 is 2, 5 minus 0 is 5. Got to regroup. 10 minus 7 is 3, and 6 minus 2 is 4. Okay, then I've got to do the inverse of squaring something, which is finding the square root. So I find the square root of these. I know the square root of x squared is going to be x, and I know that the square root of 43.52 is going to be somewhere between the square root of 49, which is a little high, and 36, which is low. Square root of 36 is 6, the square root of 49 is 7, so my answer is going to be somewhere between 6 and 7. Well, how do I get that estimated answer? Well, I know it's going to be 6 point something, so it's going to be a fraction, 6 and some fraction. What's that fraction going to be? Well, to find my denominator, I need to find the difference between my two perfect squares. The difference between 36 and 49 is 13. Okay, 49 minus 36 is 13. And then to get my denominator, I need to find the difference between my first perfect square and the number that I'm trying to find the square root of, which is 43.52. And when I subtract those, 36 from that, I'm going to get 4. Whoops, no, I'm going to get 7, sorry. 7 and 52 hundredths. 43 and 52 hundredths minus 36 is going to be 7 and 52 hundredths. So that technically is my answer. 6 and 7 52 hundredths 13ths. Okay, which is a very sloppy number. Let's clean this up a little bit and let's make a decimal out of it.
Please call trainer number 2. Mr. Holland, please call trainer 2.
So I take 7.52, okay, and divide it by 13. Every fraction is a division problem, and when I divide, I get a decimal answer. 13 will go into 75. Ooh, I'm going to say 5. Let me see. Yeah, it's got to be, ooh, yeah, 5 times 6 would be too much. So 5 times 3 is 15. Carry the 1. 5 times 1 is 5, plus the 1 is 6. Okay, and I get a remainder of 10. I bring down a 2. 13 goes into 102. Well, it's going to be 5. Let me see. 6, 7. 7 times. 8 would be a little too high, so 7 times. 7 times 3 is 21. Carry the 2. 7 times 1 is 7, plus the 2 is 9, which is going to give me a remainder of 11. And I can stop there because I think if you read the directions carefully, it said round each number to the nearest tenth. So I know it's going to be 6 and 57 hundredths. Okay, remember I did 6 and 7.52 thirteenths, and I just cleaned that up to make it a decimal. And if I want to round this to the closest hundreds, it would be 6.6. Okay, and that would be in inches. So I could put that over there. A lot of work, not that hard, but it is a lot of work. Okay, boys and girls, let's take a look at the word problems on the back. Let's specifically look at number 6. Now, the way we're going to solve these problems is we need to read the problem first, create a sketch of the problem, label the problem, which we should have some kind of triangular figure in our picture, and then use the Pythagorean theorem to solve our problem. Okay, so a ramp is placed from a ditch to the main road. It's 2 feet above the ditch. If the length of the ramp is 12 feet, how far away? So, okay, we've got our ditch here. Okay, the ramp is placed above it. Okay, it says that the length of the ramp is 12 feet. It says that the ramp is placed from a ditch to the main road 2 feet above, so it's 2 feet high. How far away is the bottom of the ramp from the road? Okay, so we want to find this bottom length here. Let's use the Pythagorean theorem. We've got a squared plus b squared is equal to c squared. The height is 2. The base we don't know. That's how far the bottom is away from the road. We know the length of the ramp, that's c, that's our hypotenuse. That's 12 squared. So we have 4 plus b squared is equal to 144. We subtract 4 from both sides. And we get b squared is equal to 140. Okay, and we want to find the square root of b squared, which is b. Okay, well, again, 140, unfortunately, is not a perfect square, but it's somewhere between the perfect square of 144, which would be, whoops, I did it backwards. Okay. Okay. The perfect square of 144 would be too high, so it's less than 12. But it would have to be, whoops, greater than the square root of 121, which is 11. And it's going to be closer to 144. So it's going to be 11 point something, and it's probably going to be somewhere around 7, 11.7. Let's see. So I want to find out that the span from 121 to 144, that's going to be 23. And how far along am I from that span? Well, what's the difference between 121 and 144? I think it's going to be 19. Okay. So it's the exact answer, or I should say approximate answer, is going to be 11. The square root of 140 is 11 and 19 23rds. But let's round that. So I take 19 to the nearest tenth. We want to round this to the nearest tenth. 23 won't go into 19, but it will go into 190. Let's see, we got 4 would be real close to 100. I'm going to say 5 times.
Miss Gifford, dial 112, please. Miss Gifford, dial 112.
5 times 3 is 15. Carry the 1. 5 times 2 is 10 plus the 1. Wow, I'm way off. Okay. Wow, I don't know what I was thinking with that estimation there. Okay, it's got to be a lot more than 5. Okay, let me go back to that. Good. Okay, so we've got maybe 9 times. See? 8 times. Let's try 8. 8 times 3 is 24. Carry the 2. 8 times 2 is 16. Plus the 2 is going to be 18. Okay, well, I said 11.7. I was pretty close. Okay, and when I go to subtract, I'm going to get a difference of 6. Bring a 0 down, and it's going to be 2. So it's going to be 11.8. And I should make that an approximation. It's approximately 11.8. Because 11 and 19 23rds rounds to 11.8. I will see you tomorrow. I got to go. As always, boys and girls, I hope that was helpful. And if you have any questions, please bring them to class tomorrow. Bye-bye.